From Earth, the planets look close. Mars appears as a small red light in the night sky. Jupiter shines like a bright star. Saturn looks peaceful, almost reachable. But this is an illusion, because space does not show distance honestly. It hides it. On a screen, the planets look lined up. In drawings, they seem close together. But in reality, the distance between planets is so enormous, so empty, and so difficult to cross that even reaching our closest neighbors becomes a challenge measured in months, years, and sometimes decades. The Moon is only our first step. Mars is already far. Jupiter is another world of distance entirely. And Neptune? Neptune is so far away that sunlight itself takes hours to reach it. Tonight, we go beyond the simple pictures of the solar system and explore the terrifying truth about how far apart the planets really are. Welcome to What If Beyond. And if you're ready to see space differently, consider subscribing before we begin. Because after tonight, the solar system may never feel small again. From Earth, the solar system looks almost simple. A bright sun in the center, a few planets moving around it, small dots of light crossing the night sky. Mars glows red. Jupiter shines brighter than most stars. Saturn hides its rings from the naked eye, but in our imagination, it feels familiar, almost close. And because we have seen the solar system so many times in books, animations, classrooms, and documentaries, we begin to believe we understand it. We imagine the planets lined up neatly. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, one after another, like stepping stones, like destinations on a cosmic road. But that picture is wrong, not because the order is wrong, but because the scale is missing. The solar system, shown in most images, is not a map. It is a symbol, a simplified drawing, a way for the human mind to fit something impossible onto a screen. Because if the planets were shown at their true distances, most of the image would be empty, almost completely empty. The planets would become tiny dots separated by enormous black spaces. Earth would not sit comfortably near Mars. Jupiter would not feel like the next large object after the asteroid belt. Neptune would not look like the final marble at the edge of a simple diagram. Instead, the solar system would feel like a vast, dark ocean, with a few islands scattered so far apart that each one seems almost alone. This is the first truth about planetary distance. The solar system is not crowded. It is mostly empty. And that emptiness is difficult to understand because our lives are built on human distances. A city feels large. A country feels larger. An ocean feels enormous. But on Earth, even the farthest places are still close compared to space. You can cross continents in hours by plane. You can send a message to the other side of the planet instantly. You can look at a globe and understand the shape of the world in one glance. Earth is huge to us, but in space, Earth is small. And the distance between Earth and anything else is where the real shock begins. The Moon is the closest major world to us. It feels familiar. It lights up the night. It shapes tides. It has been part of human stories since before civilization. And because it is so visible, the moon feels near. But the moon is about 384,000 kilometers away. That distance is already difficult to imagine. If you could drive a car straight upward toward the moon at highway speed, without stopping, without slowing, without needing fuel, it would take months. The moon looks close because it is bright. But brightness is not nearness. It is simply sunlight reflecting off a world far above us. When the Apollo astronauts traveled there, it took them about 3 days. 3 days to reach the closest celestial body humans have ever visited. That achievement was extraordinary. But in terms of the solar system, the moon is barely outside Earth's front door. It is close enough that Earth still dominates the sky. Close enough that communication delay is small. Close enough that a mission can be planned, tracked, and supported from the ground. The moon is distant, but it is not deep space. It is the first step, and the moment we move beyond it, the scale becomes much harder. Mars is often described as our neighbor, the red planet, the next world, the place where humans may one day build the first settlement beyond Earth. And in many images, Mars appears close, a small red sphere beside our blue one. But in reality, Mars is not sitting next to Earth. Both planets are moving around the Sun at different speeds and distances. Sometimes they are closer. Sometimes they are incredibly far apart. At their closest, Earth and Mars can be tens of millions of kilometers apart. At their farthest, they can be hundreds of millions of kilometers apart. That means Mars is not one fixed distance away. It is a moving target, a world that only becomes convenient to reach during certain windows, when the orbits line up in a useful way. This is why missions to Mars are not launched whenever we want. They are timed. They wait for the planets to be in the right positions, because in space, distance is not just where something is. It is where something will be when you arrive. A mission to Mars usually takes months, not because Mars is the edge of the solar system, but because even the closest planet we dream of visiting is already separated from us by a distance so large that speed, fuel, timing, and orbital mechanics all become part of the journey. And during those months, Earth slowly changes behind you. At first, it is still a world. Then it becomes smaller. Then it becomes a bright point. And eventually, for a human crew, Earth would no longer feel like a place nearby. It would become home behind them, too far away to return quickly, too far away for rescue, too far away for comfort. This is what distance does in space. It does not only separate objects, it changes the emotional meaning of travel. A journey to Mars would not be like flying to another country. It would be leaving the entire human world behind. Every person you know, every ocean, every city, every sound of Earth, all reduced to a planet shrinking in the window. And Mars is still one of the closest destinations. This is where the scale begins to feel almost cruel. If the moon takes days and Mars takes months, then the outer planets belong to another kind of distance completely. Jupiter is the largest planet in the solar system. It is so massive that it feels like a system of its own, a giant world surrounded by dozens of moons including some that are larger than planets or nearly planet-sized in character. Europa, with its hidden ocean. Ganymede, the largest moon in the solar system. Callisto, ancient and heavily scarred. Io, violent and volcanic. To look at Jupiter through a telescope is to see a destination that feels alive with possibility. But Jupiter is far, very far. Robotic spacecraft have taken years to reach it, and those spacecraft do not need air. They do not need food. They do not need sleep. They do not get lonely. They do not worry about returning home. For a human crew, Jupiter would be a much greater challenge, not just because of distance, but because of radiation, gravity, mission time, life support, and the psychological weight of being so far from Earth. By the time humans could reach the Jupiter system, the sun would still be bright, but Earth would be far behind. Communication would take much longer. A message sent home would not feel like a conversation anymore. It would feel like speaking into delay. A question sent across space, an answer returning from the past. And yet, Jupiter is not the end. Beyond it lies Saturn. Saturn is one of the most beautiful worlds we know. Its rings make it look almost unreal. A planet designed by imagination, but beauty does not make it close. Saturn is even farther. A human mission there would require years of travel with current or near-future ideas. And the deeper we go, the more sunlight weakens. The sun, which fills Earth's sky with warmth, becomes smaller and less dominant. Out near Saturn, sunlight is still there, but not like home. It is dimmer, colder, less immediate. And beyond Saturn, the solar system becomes quieter. Uranus, Neptune, worlds so distant that humans have only briefly visited them through robotic flybys. No human-made object has ever orbited Uranus or Neptune. We know them from images, measurements, models, and brief encounters. They are part of our solar system, but they feel almost like another realm. Neptune is so far that sunlight takes hours to reach it. Think about that. On Earth, sunlight feels instant. Morning comes and the world brightens. But light itself has travel time. From the sun to Earth, it takes about 8 minutes. From the sun to Neptune, it takes over 4 hours. That means Neptune receives sunlight that has been traveling through space for hours before touching its clouds. And if light takes hours, a spacecraft takes years. The outer planets reveal the true structure of the solar system. It is not a tight family of worlds sitting comfortably around the sun. It is a vast, stretched system where each planet occupies its own enormous region of emptiness. The spaces between them are not small gaps. They are oceans of darkness, and most diagrams hide this. They have to. If they didn't, they would be almost useless. To fit the sun, planets, and distances on one page, the truth must be compressed. The planets must be enlarged. The distances must be shortened. The emptiness must be removed. Otherwise, the viewer would see almost nothing. This has shaped how we imagine space. We know the solar system is large, but we do not feel it. We see planets placed close together and unconsciously accept that closeness. We watch animations where a spacecraft crosses from world to world in seconds. We see movies where ships move between planets like cities. But real space is slower, emptier, less forgiving. The distance between planets is not just worse than we think. It is worse than we are trained to imagine. Because humans are visual creatures. We trust images, and the images of the solar system we grow up with are not built for scale. They are built for understanding. But understanding the order of planets is not the same as understanding their distance. It is like looking at a map of Earth, where every city is drawn beside the next, with no real space between them. You could learn the names, you could learn the order, but you would not understand the journey. And space is all about the journey. The distance changes everything. It changes how long missions take, how much fuel is needed, how much food must be carried, how much radiation a spacecraft must survive, how lonely the crew becomes, how delayed communication feels, how dangerous every system failure becomes. On Earth, distance can be inconvenient. In space, distance can be deadly. If something breaks on a spacecraft near Earth, there may be options. Return quickly, receive help, send supplies, adjust the mission. But if something breaks months away from Earth, the crew may be alone. If something fails near Jupiter or Saturn, help is not coming in time. Distance turns small problems into existential problems. A broken part is not just mechanical, it becomes survival. A medical emergency is not just urgent, it becomes isolated. A communication delay is not just annoying, it changes decision-making completely. This is why the distance between planets matters so much. It is not trivia. It is the real wall behind space exploration. When we say Mars is close, we mean close compared to the outer planets. When we say Jupiter is far, we mean far compared to Mars. But compared to the nearest star, even Neptune is still close. This is the strange layering of cosmic distance. The Moon is far compared to Earth. Mars is far compared to Mars. Neptune is far compared to Jupiter, and the nearest star is so far compared to Neptune that the entire solar system begins to feel small again. The human mind keeps being forced to reset. Every time we think we understand the scale, space expands the frame. This is why the solar system is both familiar and terrifying. It is our home region, our neighborhood, the place where Earth, the Sun, the planets, moons, asteroids and comets all belong. But even this neighborhood is too large for humans to cross easily. We have lived on Earth for all of history. We have visited the Moon. We have sent robots across the solar system. But human footsteps have not reached Mars. No human has seen Jupiter with their own eyes from nearby space. No human has stood beneath Saturn's rings. No human has watched the Sun from Neptune and felt how small it looks. Those worlds exist in our imagination, but not yet in human experience. And maybe that is what makes the distance feel so powerful. The solar system is not just a collection of planets. It is a reminder of our limits. We can see far, we can calculate far, we can send machines far. But going there ourselves is another question, a harder question, a slower question, one that forces us to respect the emptiness between worlds, because the distance between planets is not just a number, it is time. It is risk. It is isolation. It is everything a human mission must survive before reaching the destination. And once we understand that, the solar system changes. Mars no longer feels like a nearby red dot. Jupiter no longer feels like the next giant planet in a simple line. Saturn no longer feels like a beautiful image waiting in the dark. They become what they truly are. Separate worlds, divided by immense emptiness, each one requiring a journey long enough to change the meaning of travel itself. And this is only the beginning. Because once you understand the distance between Earth and the planets, you begin to realize something even more unsettling. The planets are not waiting close together. They are drifting through a system so large that even light needs time to cross it. And humans, small, fragile, and brief, are only beginning to learn how far really means. If the planets were standing still, space travel would already be difficult. But they are not standing still. That is the next problem. Every world in the solar system is moving. Earth is moving around the sun. Mars is moving around the sun. Jupiter, Saturn, Uranus, and Neptune are all moving too. Nothing waits. Nothing stays in one place. The solar system is not a row of planets sitting beside each other, waiting for a spacecraft to fly from one to the next. It is a moving system, a dance of worlds traveling at different speeds, on different paths, across enormous distances. And this changes everything. When people imagine traveling to another planet, they often imagine pointing a rocket toward it and flying straight there. Earth here, Mars there. Draw a line, go. But real spaceflight does not work like that. Because by the time your spacecraft reaches the place where Mars was, Mars has moved. A planet is not a target. It is a moving target. And your spacecraft is moving too. It does not simply leave Earth like a car leaving a driveway. It already has Earth's orbital speed around the Sun. So when a rocket launches, it is not starting from stillness. It is starting from a planet that is already racing through space. Earth moves around the Sun at roughly 30 kilometers per second. You do not feel that speed because everything around you is moving with Earth. The ground, the air, the oceans, your body. But from the perspective of the solar system, Earth is already flying. So a spacecraft leaving Earth carries that motion with it. It must escape Earth's gravity, but it also becomes part of the Sun system. It enters an orbit. It follows curves. It must use timing, speed, and direction carefully. Space travel is not like shooting an arrow at a target. It is more like stepping from one moving carousel to another, while both are spinning around the same center. This is why launch windows matter. To reach Mars efficiently, you wait until Earth and Mars are positioned in a way that allows a spacecraft to follow a curved path from one orbit to the other. That path is not the shortest line. It is not the fastest path possible. It is the path that balances fuel, timing, and orbital motion. The spacecraft does not chase Mars directly. It travels along an arc around the Sun, and Mars arrives at the meeting point later. The mission works only if everything is timed correctly. Launch too early, and Mars is not there. Launch too late, and the spacecraft misses the best path. This is one of the reasons Mars missions happen during specific windows, roughly every 26 months. Not because humans choose that rhythm, but because the planets do. The solar system sets the schedule, and humanity must wait. That waiting reveals something important. Even our closest planetary neighbor is not always conveniently reachable. Mars may look like the next step, but it does not stay in the same place. Sometimes it is on the same side of the Sun as Earth. Sometimes it is far across the solar system. Sometimes the distance is reasonable for a mission. Sometimes it is terrible. This means the distance between planets is not one number. It is a changing relationship, a constant motion problem. And the farther out we go, the more complicated that relationship becomes. Jupiter takes almost 12 Earth years to orbit the Sun. Saturn takes nearly 30. Uranus takes 84. Neptune takes about 165. These planets move more slowly in their orbits than Earth, but they are so far away that reaching them requires careful planning across years. A spacecraft may need to use the gravity of other planets to gain speed or change direction. This is called a gravity assist. It is one of the most elegant tricks in spaceflight. A spacecraft flies near a planet and uses that planet's motion and gravity to alter its own path. It can gain speed, it can redirect, it can reach places that would otherwise require much more fuel. But gravity assists depend on alignment. The planets must be in the right positions. If they are not, the opportunity may not exist. This is why some historic missions were possible because of rare planetary arrangements. The solar system occasionally creates pathways, not roads, not bridges, but opportunities, moments when moving worlds line up just enough for a spacecraft to use them. And then the window closes. The planets continue their motion. The path disappears. This makes the solar system feel less like an open field and more like a giant moving clock. Every gear turns at a different speed. Every destination shifts. Every journey depends on the timing of the entire system. And that is difficult for the human mind to feel, because when we look at a planet in the sky, it seems fixed, a point of light, still, peaceful. But that stillness is an illusion created by distance. Mars is moving. Saturn is moving. Everything is moving. Even the Sun is not truly still. The entire solar system moves around the center of the Milky Way, and the Milky Way itself moves through space. But for planetary travel, the local motion is already enough to make every journey complicated. A planet is not just far away. It is far away while moving, and you must meet it in the future. This idea changes the meaning of distance. On Earth, if you want to travel to a city, the city stays where it is. You can leave today or tomorrow. The road may change, but the destination remains fixed. In space, the destination is always somewhere else by the time you arrive. So the mission is built around prediction. Where will Mars be months from now? Where will Jupiter be years from now? How fast must the spacecraft travel? How much fuel can it use? Can it slow down when it gets there? Can it enter orbit? Can it survive the environment? Every answer depends on time. This is why the distance between planets is worse than a simple number. It is not just distance. It is distance plus motion, distance plus timing, distance plus energy, distance plus risk. A spacecraft does not only cross emptiness, it negotiates with gravity. Gravity is everywhere in the solar system. Earth pulls, the moon pulls, the sun dominates. Every planet bends paths. Every object moves according to invisible forces. A spacecraft must work with those forces, not ignore them. To leave Earth, a rocket must climb out of Earth's gravity well. But escaping Earth is only the beginning. The sun is still holding the spacecraft. To go farther from the sun, the spacecraft must change its orbit. To go inward, toward Venus or Mercury, it must lose orbital energy. To go outward, toward Mars or beyond, it must gain energy. This is not intuitive. People often imagine that going toward the sun is easy because the sun pulls everything inward. But reaching inner planets, like Mercury, can be extremely difficult because Earth is already moving very fast around the sun. To fall closer to the sun in a controlled way, a spacecraft has to reduce its sideways orbital motion. That requires energy. So even destinations that seem closer to the sun are not simple. Space does not care about how the map looks. It cares about orbits. This is why planetary travel is one of the most beautiful and frustrating forms of navigation ever invented. You do not simply aim. You calculate. You wait. You curve. You borrow gravity. You conserve fuel. You accept that the most efficient route may look nothing like a straight line. And still, the journey takes time. A lot of time. Imagine a spacecraft heading toward Mars. For months, it travels through empty space. No landscapes pass beneath it. No stations appear along the way. No road signs. Only instruments, stars, and the growing distance from Earth. Mars slowly becomes larger ahead. Earth slowly becomes smaller behind. And all the while, the crew or the machine is trapped inside the logic of the transfer path. It cannot simply stop halfway. It cannot turn around easily. It cannot pull over. In space, motion is commitment. Once a spacecraft is on its path, changing that path requires fuel, and fuel is limited. Every correction must be planned. Every burn matters. Every mistake costs energy that may be needed later. This is another reason distance becomes dangerous. The farther you go, the fewer options you have. Near Earth, mistakes can sometimes be corrected quickly. Far from Earth, every correction becomes more expensive, slower, and more serious. A mission to Mars already demands precision. A mission to the outer planets demands patience and trust in calculations across years. A human mission would demand even more, Because humans cannot be treated like instruments. They need safety margins. They need backup plans. They need life support. They need a way to survive delays. And delays are built into deep space travel. Even communication is limited by light speed. This is another part of planetary distance that many people forget. When you speak to someone on Earth, the signal feels instant. A video call across the planet may have small delays, but it still feels like conversation. With the Moon, the delay is noticeable but manageable. With Mars, communication delays can range from several minutes to over 20 minutes one way, depending on the positions of Earth and Mars. That means a question and answer could take tens of minutes. You cannot have a normal conversation. You send a message. You wait. The reply comes from the past. For astronauts on Mars, this would change everything. Mission control could not guide every moment in real time. If something goes wrong, the crew must respond on their own. They cannot ask Earth and wait for instructions if the emergency is immediate. The distance forces independence. And beyond Mars, the delay grows even more. At Jupiter, signals can take more than half an hour one way, often longer depending on positions. At Saturn, over an hour. At Uranus and Neptune, multiple hours. A spacecraft near Neptune is not having a conversation with Earth. It is exchanging messages across a gulf so large that even light becomes slow. This is perhaps one of the most haunting truths about the solar system. Light is the fastest thing in the universe, and even light takes hours to cross the outer solar system. So what does that say about humans? About rockets? About fragile bodies inside metal ships? It means distance is not just physical. It becomes emotional. A crew far from Earth would experience a strange kind of loneliness, not because they cannot send messages, but because Earth can no longer respond in the rhythm of human connection. A message home becomes a recording. A reply becomes an echo. The farther they travel, the more they live outside Earth's immediate presence. At some point, they are not simply away from home. They are delayed from home, separated by time as well as distance. That changes the psychology of exploration. On Earth, distance can be crossed by communication. You can be far away and still feel connected. In deep space, even connection slows down. Human emotions must adapt to light time, and light time does not adapt to humans. This is why planetary distance feels worse than diagrams show. A diagram can show empty space, but it cannot show waiting. It cannot show a crew listening to silence after sending a message. It cannot show the knowledge that if something goes wrong, Earth may not even hear about it until minutes or hours later. And by the time Earth answers, the situation may already be over. The deeper we travel, the more the mission must become self-reliant. A ship to the outer planets would need decision-making on board, artificial intelligence, trained crews, strong autonomy, and systems capable of handling failure without Earth. The spacecraft becomes less like a vehicle controlled from home and more like a remote settlement moving through space. This is one of the hidden meanings of distance. It forces maturity. The farther humans go, the less they can depend on Earth in real time. They must become their own world, their own repair crew, their own medical team, their own emergency response, their own small civilization. And this would begin long before we ever reach another star. Even within the solar system, distance teaches independence. Mars would be the first major test, not just of landing, not just of survival, but of living with delay, living with limited help, living with the knowledge that Earth is not close enough to rescue you quickly. Then the outer planets would push that further. A mission near Jupiter or Saturn would be an expedition into deep isolation. The Sun would be smaller. Earth would be distant. Communication would be slow. The journey would be long enough that the people on board might change during the mission. Not physically only, but psychologically. They would leave as one version of themselves and return, if they returned at all, as someone shaped by years of distance. This is why the distance between planets is not only an engineering problem, it is a human problem. The planets are separated by emptiness so large that travel becomes transformation. A person going to Mars is not simply visiting another place. They are accepting a period of life outside Earth's immediate reach. A person going to Saturn would be accepting years inside a mission where home becomes a delayed memory. A person going to Neptune would be entering a level of separation no human has ever experienced. And still, Neptune is part of our own solar system. This is the part that feels almost unbelievable. The solar system is our neighborhood, our home region. The planets are our closest worlds, and yet reaching them is so difficult that even the nearest ones demand months, and the farthest demand years or more. If this is the distance between neighbors, then the distance between stars becomes almost beyond language. But before we reach the stars, we have to understand the solar system honestly, not as a classroom diagram, not as a clean line of planets, but as a moving, empty, enormous structure where every planet is separated by time, gravity, speed, and silence. A spacecraft moving through it is not crossing a simple gap. It is entering a changing system. The planets are not waiting. The paths are not straight. The windows are not always open. Communication is not instant. Help is not close. And every kilometer deeper into space makes Earth less immediate. That is why the distance between planets is worse than most people think. Because the problem is not only that they are far apart, it is that they are far apart in motion, far apart in time, far apart in light, far apart in human experience. And once you understand that, the solar system stops looking like a neat family of worlds. It becomes what it truly is, a vast machine of moving planets, separated by oceans of darkness, where every journey is a race against distance, timing, and the limits of life itself. There is another illusion that makes the solar system feel smaller than it is: speed. When we watch animations of spacecraft moving between planets, the journey looks smooth, fast, almost effortless. A ship leaves Earth. A blue trail appears behind it. Mars grows larger. Jupiter appears next. Saturn waits beautifully in the distance. In only a few seconds, the spacecraft crosses a solar system that, in reality, would take months, years, or even decades to travel through. Animations compress time because they have to. If they showed the real journey at real scale, almost nothing would seem to happen. A spacecraft would move through darkness for a long time. The planets would remain tiny. The destination would barely grow, and the viewer would start to feel the truth. Space travel is not dramatic most of the time. It is waiting, long stretches of waiting. A spacecraft does not roar through the solar system like a vehicle on a highway. Once it leaves Earth, most of the journey is quiet. No engines firing constantly. No nearby planets passing every few minutes. No glowing space lanes. Just a small object following a calculated path through a huge emptiness. That emptiness is the real face of the solar system. The planets are rare. The distance is common. And when we imagine traveling from Earth to another planet, we often focus on the destination: Mars, Jupiter, Saturn, Neptune. But the journey is mostly the space between them, and that space is almost completely empty. This emptiness is not like a desert on Earth. A desert still has ground, air, temperature, wind, a horizon, a sense of place. The emptiness between planets has none of that. No air, no surface, no sound, no shelter, no natural source of food or water, no emergency stop, no place to land halfway. A spacecraft moving between planets is not crossing a landscape. It is crossing absence, and absence is difficult to show in a thumbnail, a diagram, or a short animation. That is why people underestimate it. They see the planets. They do not feel the gap. Imagine Earth as a small ball. Now imagine the moon as a tiny object placed far away from it. Already, the distance surprises people when it is shown correctly. But then, imagine placing Mars at its true scale and distance. Suddenly, the room is not enough. A building may not be enough. A city may not be enough, depending on the scale. Then Jupiter must be placed much farther still. Saturn farther again. Uranus and Neptune so far away that the model becomes almost impossible to fit into ordinary space. That is the problem with the solar system. The sizes of the planets are interesting, but the distances are overwhelming. Jupiter is enormous compared to Earth, but even Jupiter becomes a small object when placed at its real distance from us. Saturn's rings are magnificent, but from Earth, Saturn is so far that even light takes over an hour to cross that distance, depending on where the planets are. The beauty of the planet does not reduce the journey. The rings do not make Saturn closer. The images we see from telescopes and probes make these worlds feel familiar. But familiarity is not proximity. We know what Jupiter looks like. We know the shape of Saturn's rings. We have maps of Mars. We have pictures of Neptune. But knowing a world visually does not mean it is easy to reach. In fact, this may be one of the strangest parts of modern space exploration. We can see places much more easily than we can visit them. A telescope can bring Jupiter into view in a backyard. A spacecraft camera can send back images from the outer planets. A space telescope can show galaxies billions of light years away, but our bodies remain trapped by distance. Our eyes can travel across the universe through light. Our machines can travel slowly through space. But humans themselves are still bound to the inner edge of exploration. We have looked far deeper than we have gone. That gap between seeing and traveling creates a false sense of closeness. Mars feels close because we have seen its surface in detail. Jupiter feels familiar because its storms appear in countless images. Saturn feels almost known because its rings are iconic. But these worlds are not close. They are only visible. There is a difference, a very important difference. A mountain visible on the horizon may still be hours away. A star visible in the sky may be years of light away. A planet visible through a telescope may still require an enormous mission to reach. The universe allows us to see far, but it does not allow us to travel far easily. This is why the distance between planets becomes more shocking the more seriously you think about it. The Moon, our closest major companion, is already far enough that humans needed one of the greatest engineering efforts in history to reach it. Mars, the next great dream, requires months of travel and years of planning. Jupiter demands a journey that moves from exploration into endurance. Saturn pushes that endurance even farther. Uranus and Neptune belong to a region so distant that even robotic missions become rare, expensive, and extremely long. And beyond Neptune, the solar system does not simply end. It fades. The sun's gravity continues outward. Small icy bodies orbit in distant darkness. Comets may wait in regions so far away that they are barely part of our daily idea of the solar system. The familiar planets are only the bright, named landmarks. But the sun's domain stretches far beyond them. This means the solar system is not just 8 planets. It is a vast gravitational territory, a huge region of influence, a place where worlds, moons, asteroids, comets, dust, and invisible forces all move around one star. And Earth is only one small part of it. From Earth, we feel central because this is where life is. But physically, Earth is not central. It is one moving planet among many, a tiny blue world inside a much larger structure. And the distances between those worlds are not empty in a poetic sense only. They are empty in a practical sense. There is almost nothing there that can help you survive. This is why traveling between planets is not like sailing between islands. When sailors crossed oceans, the ocean was dangerous, but the ship still floated on something. There was water, there was wind, there were currents, there were fish, there was weather. In space, the ship floats on nothing. It is not supported. It is not carried. It is simply moving because physics allows it to keep moving. If the engine stops, the spacecraft does not fall like an airplane. It continues along its path. That may sound comforting, but it also means there is no simple way to change your situation. No road, no harbor, no nearby rescue. A spacecraft is committed to the path it has, and across planetary distances, that commitment becomes serious. If a mission is halfway to Mars, it cannot instantly return. If it is on its way to Jupiter, It cannot simply turn around like a car. Changing course requires fuel. Fuel requires planning. Planning requires precision. And precision becomes more important the farther the mission goes. This is why space agencies calculate trajectories with extraordinary care. A small error early in a journey can become a large miss later. A tiny difference in speed or angle can matter after millions of kilometers. Space magnifies mistakes. Distance gives small errors time to grow. That is another reason the distance between planets is worse than people think. It makes everything less forgiving. On Earth, if you are slightly off course, you correct it. In space, every correction costs fuel, and fuel is one of the most precious things a spacecraft has. A mission must carry enough to launch, adjust, maneuver, and sometimes slow down. For robotic missions, engineers can accept certain risks. For humans, the standards are much higher. A human spacecraft needs more mass, more safety, more redundancy. That makes the distance even harder. A camera can be sent to Mars. A rover can land and operate slowly. But a human crew needs life support, shielding, food, space to live, medical supplies, emergency systems, and a return plan. The same distance becomes much more difficult when life is inside the vehicle. The distance between planets is not just measured in kilometers, it is measured in everything required to keep humans alive across those kilometers. Air, water, food, power, radiation shielding, psychological stability, mechanical reliability, communication, navigation, return capability. Each one adds complexity. Each one adds weight. Each one makes the mission harder. This is why robotic explorers have gone much farther than humans. Robots can survive what humans cannot. They can travel for years inside small spacecraft. They can sleep during quiet phases. They can endure conditions that would be impossible for a living crew. They do not need comfort. They do not need hope. They do not need to see Earth again. A robot can spend years crossing space for a brief flyby. A human cannot be treated the same way. For humans, travel time is lived time. Every day of the journey is a day inside the mission. Every month is a month away from Earth. Every year is a year in an artificial environment. This changes how we should think about reaching other planets. When we say a mission to Saturn might take years, we are not just talking about a number. We are talking about years of human life spent inside a spacecraft. Years without oceans, without open sky, without ordinary weather, without walking naturally under Earth gravity. Years where the crew depends completely on systems that cannot fail. That is not simply transportation. That is a new form of existence. And the farther the destination, the more the journey becomes the main experience. For a short trip, the destination defines the mission. For a long trip, the journey defines the life. This is why deep space travel feels different from any exploration humans have done before. On Earth, explorers crossed deserts, oceans, and polar regions. Those journeys were dangerous, but they still happened inside Earth's environment. Space removes that environment entirely. It asks humans to survive inside machines while crossing distances larger than human culture was built to imagine. And even when the destination is reached, the distance does not disappear. It remains behind you. A human on Mars is still months from Earth. A human near Jupiter is still years of travel away. A human near Saturn is even more isolated. Arrival is not the end of distance. It is only the beginning of a new relationship with it, because once you arrive, you still need supplies, communication, return options, emergency plans. If the planet or moon is hostile, you need habitats. If the environment is cold, you need heat. If radiation is high, you need shelter. If gravity is weak, you need medical countermeasures. The distance makes every problem harder to solve. This is why Mars is such a major step. Not because it is the farthest place we can imagine, but because it is the first place far enough to force humans into a new level of independence. The moon is close enough that Earth still feels present. Mars is far enough that Earth becomes delayed. The outer planets would be far enough that Earth becomes distant in a way no human has ever experienced. So the solar system is like a series of psychological thresholds. The moon teaches us to leave Earth. Mars teaches us to live away from Earth. The asteroid belt teaches us to operate in the space between worlds. Jupiter and Saturn teach us to survive in the deep solar system. Uranus and Neptune would teach us what it means to explore the edge of our planetary neighborhood. Each step is not just farther. Each step is stranger, because distance changes the mission. It changes the relationship to home, and it changes the people who travel. A crew leaving for Mars may still feel like astronauts. A crew leaving for Saturn may feel more like settlers, even if they plan to return. A crew leaving for Neptune would be doing something closer to a lifetime expedition. The distance itself would become part of their identity. And perhaps this is what diagrams never show. They show the planets. They show the order. But they do not show the human meaning of the gap. They do not show how long silence feels. They do not show how small Earth becomes. They do not show how a crew changes after years inside a ship. They do not show the fear of a system failing when home is too far away. They do not show that space is not only distance, but separation. Separation from rescue. Separation from normal life. Separation from the planet that shaped every part of us. This is why the distance between planets is worse than you think. Because the numbers are only the surface. The real distance is experienced in time, in danger, in dependence on technology, in the inability to turn back easily, in the way communication slows down, in the way Earth becomes a memory instead of a place outside the window. And once you understand this, even the solar system begins to feel enormous. Not the galaxy, not the universe, just our own solar system, our home, the place we belong. It is already so large that we have only physically touched one world beyond Earth. Everything else remains, for now, a destination for machines, mathematics, and imagination. The planets are real. They are there. They move around the same sun. They share the same cosmic neighborhood. But they are not close in the way our minds want them to be. They are separated by oceans of darkness that make every journey difficult and every arrival extraordinary. And maybe that is the lesson of part 3. The solar system is not small because it is familiar. It is not easy because we can name its worlds. And it is not close because we can see its planets in the sky. The solar system is vast. The gaps are real. And every planet we dream of reaching is waiting behind a distance that must be survived, not just crossed. By the time you reach the outer solar system, the meaning of distance begins to change. It is no longer just a measurement. It becomes an atmosphere, a feeling, a kind of silence that grows larger the farther you move from the sun. Near Earth, space still feels connected to home. The sun is bright. The moon is close. Mars is difficult, but imaginable. Even the idea of crossing millions of kilometers still belongs to a human kind of ambition. It sounds hard, but not impossible. But when you move farther outward, past Mars, past the asteroid belt, past Jupiter, something begins to happen. The solar system stops feeling like a neighborhood. It starts feeling like an empire of emptiness. Jupiter is already far enough to humble any idea of easy travel. Saturn is farther still. And beyond Saturn, the familiar solar system begins to fade into something colder, darker, and less human. Uranus and Neptune are not simply distant planets. They are reminders that the sun's family stretches far beyond the places our minds naturally imagine. At Neptune, the sun is still the center of the system. But it no longer feels like the sun we know. From Earth, the sun dominates everything. It warms the ground. It fills the sky. It creates morning, afternoon, shadow, weather, seasons, and life. But from Neptune, the sun is just a brilliant point, still powerful, still but emotionally distant, a star among darkness. And this may be one of the strangest truths about planetary distance. The sun does not disappear all at once. It slowly loses its intimacy. The farther you go, the less it feels like the warm center of life, and the more it becomes a remote source of light. At Earth, sunlight feels like presence. At Neptune, it feels like memory. That is what distance does. It turns the familiar into something remote. It takes the same sun that shaped every living thing on Earth and reduces it to a bright object in a black sky. And if the sun itself can begin to feel distant inside its own solar system, then the planets become even more separated. Each world is isolated in its own region of space, not floating beside the others like marbles on a table, but moving through enormous zones of darkness. Mercury burns close to the sun. Venus hides beneath thick clouds. Earth carries oceans and life. Mars waits cold and red. Jupiter dominates its moons. Saturn glows softly with rings. Uranus rolls sideways in distant blue-green silence. Neptune circles in the far cold, whipped by powerful winds beneath a weak sun. They all belong to one system, but they do not feel close. They are connected by gravity, not by comfort. The distances between them are so large that every planet becomes its own world in the deepest sense, not just physically separate, emotionally separate. A traveler standing on Mars would not feel like they are simply outside Earth. They would feel that Earth has become another planet. A traveler near Saturn would not feel that Mars is nearby. Mars would be part of the inner solar system, far behind them. And Neptune would feel almost like the edge of belonging, a place where the sun still rules, but barely feels warm. This is why the distance between planets changes the way we understand home. On Earth, home feels complete. The ground beneath us, the sky above us, the moon at night, the sun in the morning. But once we imagine traveling outward, home becomes smaller. First, Earth becomes a globe, then a dot, then a direction, then a memory, and eventually the entire inner solar system becomes one small bright region behind you. This is not easy for the human mind to accept because humans are used to scale built around experience. We know what a walk feels like. We know what a drive feels like. We know what a flight feels like, but we do not truly know what a year-long journey through empty space feels like. We can describe it, we can calculate it, we can simulate it, but almost no part of ordinary human life prepares us emotionally for it. A journey to another planet is not just transportation. It is a psychological transformation. The traveler does not only move through space, they move away from every familiar rhythm their body and mind were shaped by. No normal sunrise, no natural weather, no open horizon, no sound of wind through trees, no ocean, no soil, no animals, no random human noise outside a window. Only the controlled world of a spacecraft, and outside it, the enormous quiet between planets. That quiet is the real scale. The planets are dramatic. The gaps are not, but the gaps are what dominate the journey. A mission to Mars is not mostly Mars. It is mostly travel. A mission to Saturn is not mostly Saturn. It is years of crossing darkness before Saturn finally becomes a world in the window. This is why the solar system is so often misunderstood. We focus on the destinations because destinations are interesting. Planets have color, moons have surfaces, rings have beauty, storms have movement, but the distance between them has no face. It is hard to show, hard to sell, hard to imagine. And yet, it is the distance that decides everything. It decides how long the mission takes. It decides how much fuel is needed. It decides how isolated the crew becomes. It decides how delayed communication will be. It decides how dangerous a failure becomes. It decides whether a destination is realistic or only a dream. In space exploration, distance is not background. Distance is the main obstacle. And as long as humans remain slow compared to light, the solar system will remain vast. Even if rockets improve, even if engines become stronger, Even if we build better habitats, the distances will not shrink. They will simply become more manageable. That is an important difference. Future technology may make Mars easier. It may make the asteroid belt useful. It may make Jupiter's moons reachable. It may even make Saturn a realistic destination for advanced human missions. But none of that makes the solar system small. It only means humans become better at surviving its size. The planets will still be far. The journeys will still be long. The communication delays will still exist. The emptiness will still dominate. This is perhaps the most honest way to see the future of space travel, not as a sudden conquest of the solar system, but as a slow process of learning how to live inside distance. Humans may build stations in orbit, bases on the Moon, settlements on Mars, mining operations near asteroids, research outposts near icy moons. Each one would become a stepping stone, a way to make the empty spaces less absolute. But even then, the solar system would not become easy. It would become inhabited. There is a difference. An inhabited ocean is still an ocean. A mapped desert is still a desert. A road through wilderness does not remove the wilderness. It only gives humans a way to cross it. And maybe one day, the solar system will be like that. Still enormous, still dangerous, still filled with silence, but no longer completely unreachable. Maybe future humans will not think of Mars as impossible. Maybe they will see it as distant, but known. Maybe Jupiter's moons will become the outer frontier of science and industry. Maybe Saturn will become the place people dream of seeing before they die. Maybe Neptune will remain a symbol of the far edge, a blue world so distant that only the bravest missions go there. But for us, right now, the planets remain almost entirely beyond human experience. We have touched the Moon. Everything else is still waiting. Mars has received machines, but not footsteps. Jupiter has been visited by probes, but not by human eyes looking through a spacecraft window. Saturn has been studied in breathtaking detail, but no human has watched its rings rise across a nearby sky. Uranus and Neptune remain even more remote, known but barely visited, named but still distant in the deepest way. And this should change how we feel when we look at the night sky. Mars is not just a red dot. It is a world separated by millions of kilometers and months of danger. Jupiter is not just a bright point. It is a giant system far beyond easy reach. Saturn is not just a beautiful image. It is a world so distant that arriving there would be one of the greatest journeys humans could ever attempt. The planets are not close because we can see them. They are not simple because we can name them. They are not waiting beside us because diagrams place them in order. They are far, truly far, and the only reason they feel familiar is because light crosses distance more easily than life does. A photon can travel from Jupiter to Earth in less than an hour. A spacecraft takes years. An image can reach our screens and make a planet feel near. A human mission must survive the real distance. This is the central difference. Seeing is not traveling. Knowing is not reaching. Understanding a destination is not the same as crossing the void to stand there. And the more honestly we accept this, the more incredible space exploration becomes. Because every successful mission is not just a technical achievement, it is a victory over scale. A spacecraft reaching Mars has crossed a gulf that would have been unimaginable to most of human history. A probe arriving at Jupiter has navigated years of motion, gravity, and emptiness. A mission to Saturn has survived a journey so long that the spacecraft becomes almost like a time capsule. And Voyager, still moving outward, is a reminder that even after decades, a spacecraft can still be at the beginning of interstellar distance. That is the final, humbling layer. The solar system is enormous to us, but compared to the distance between stars, it is small. The planets feel impossibly far apart, and yet they are still part of one local system, one star's family, one gravitational home, beyond Neptune, beyond the Kuiper Belt, beyond the fading influence of the sun. The nearest star waits across a darkness so vast that planetary distances become almost gentle by comparison. This does not make the solar system less impressive. It makes it more meaningful because it shows us the first scale we must master. Before humans can dream seriously of crossing to another star, we must first learn to cross our own system. Before interstellar travel becomes more than imagination, Mars must become reachable. Deep space habitats must become reliable. Life support must become nearly perfect. Radiation protection must improve. Human psychology must be understood beyond Earth. Engines must become faster and more efficient. And perhaps most importantly, humanity must learn patience. The planets do not arrange themselves for our convenience. The distances do not shorten because we are eager. The universe does not become safe because our stories make it beautiful. If we want to travel far, we must accept the truth first. The solar system is not a small playground. It is a vast structure of moving worlds, separated by oceans of darkness. And every journey through it is serious. Every destination is hard-earned. Every kilometer matters. In the end, the distance between planets is worse than you think, because our minds were never trained to imagine emptiness properly. We imagine objects. We imagine worlds. We imagine the shining things. But space is mostly the distance between them. The silence between the planets. The long waiting between departure and arrival. The invisible time that light needs to cross the dark. And maybe that is what makes the solar system beautiful. Not because it is easy, but because it is enormous. Not because the planets are close, but because they are distant, separate, and still connected by the same sun. Earth is one world among others, close enough to see them, far enough to struggle toward them, fragile enough to make the journey dangerous, curious enough to attempt it anyway. So the next time you see Mars glowing red, or Jupiter shining bright, or Saturn through a telescope, remember this: you are not looking at nearby lights. You are looking across vast emptiness, across moving orbits, across minutes, hours, months, and years of possible travel. You are seeing worlds that belong to our solar system, but still wait behind distances large enough to challenge everything we are. And perhaps that is the real lesson. The planets are not unreachable, but they are not close. They are invitations written across darkness. And humanity is still standing near the beginning, learning how to answer.